In this session, we learn sorting process. What do you mean by sorting? Sorting is arranging the items of an array either in ascending order or descending order. Arranging the items. Items may be in random order, you have seen. Array items can be as we enter. But to process sometimes it requires to be in order. So arranging the items is sorting. There are so many sorting algorithms actually. Like the basic algorithm we have seen in the first year itself, like bubble sort, simplest of algorithms, then selection sort, right? Some of the algorithms will be like this: bubble sort, selection sort, then insertion sort, then quick sort, heap sort, shell sort, etc. Many algorithms are there. But in the syllabus, the insertion sort is given. So we will learn this. So to recall this bubble sort, as you have done the bubble sort program also you have written last year, I will recall that sorting, simplest of that. Suppose if you take the items of the array like this, random. The items will be like this in random order. According to the bubble sort, what we did is first and the second we compare it. Suppose we have to arrange it ascending order. First one should be smaller than the second one. So in this case, it is just first one is smaller than the second one, right? So comparing the first item with the second item, adjacent items, this. If the first item is more than the second item, then you have to interchange. If you have to arrange in ascending order. If you have to arrange in descending order, then if the first one is smaller than the second one, then you have to interchange. So accordingly you compare and interchange. So these are the two operations need to be carried out in any kind of sorting. You have to compare the items, one item with another, then we decide whether you have to interchange or change the positions, right? All those things. So comparison and interchange, these are must operations in any kind of sorting. Here also. So this is in order. Now let us compare the second and the third one. 70 is more than 20. So we have to interchange. So 70 has to be here, 20 has to be here. 70. So 10 is there only. 20 and 70 interchange. Now compare this 70 with the next item, 80. So adjacent items, starting from the first item, next two like this, till we go to the end of the array. 70 and 80, yes, 70 is less than 80, no need to interchange. Next 80 and 30, yes, we need to interchange. 30 comes here and 80 goes here. So this is the position of the new positions of items after we carry out first set of these operations like comparison and if required interchange. So this is called pass 1. This is called pass 1. Now see the items 10, 20, 70, 30, 80. Still these are not in order. 30 is here, 70 is here. So we have to carry out the same process of comparing the items and interchanging again, right, on this, like this. 10 and 20, these are in order, 10 and 20. 20 and 70, these are also in order, 70. 70 and 30, yes, interchange. 30 here and 70 there. 70 and 80 in order, right? Like this. So this is called pass 2. So if there are n number of items, this is A of n. N is equal to 5. So in this case, we had 5 items. When there are 5 items in the array, then the number of passes in this case will be 4, n minus 1, correct? When there are n items, number of passes is n minus 1. Right? So similarly here, first two we have seen. Similarly, we have to have 2 more passes. At the end of these 4 passes, we see that all the items will be in order. But in this case, this may happen before all the passes also. Look at this example 10, 20, 30, 70, 80. All the items are already in order. So arrangement of items and making them in order, it may be completed within the number of passes also, as you have seen here. If there are n items, there can be n minus 1 passes. So this is the logic of simple bubble sort we have seen last year. But in this year, we have another like insertion sort. Let me see what is insertion sort. Now let us see this insertion sort. According to the insertion sort algorithm, I will explain the algorithm first. Later I will write the algorithm. Insertion, as the name says, we pick the second item onwards. Assume that the first item is in position. Now let us assume that 10 is in its position. 10 is in 0 index, 2, 3 and 4. Assume that the first item is in its proper position. 10. Next, take the second item, compare with the previous item. Take 70, compare with the previous is 10. If the second item is less than the previous item, then you need to interchange to put them into ascending order, correct? If the second item is less than the first item, previous item, it's the previous, you need to interchange. And again the previous item and it's the previous. Since you have taken the second element now, right, to take this item, right, this is called pivot item or key item. Key item. The one selected item is called key. So from there we compare it with its previous. So second and its previous, first one. So they are in position, no need to interchange. Second one is not less than the first, it is more than the first. So keep them as it is. So first, this is over, comparison. Next, take this third item. Take the third element as the key or pivot item. Compare with its previous. It's the previous item. Previous item is 70. Compare 20 with the previous item 70. Yes, that item is less than the previous item. So you need to interchange. Here comes 20. Here is 70. 10 is already in its position. We have seen. Compare. So comparison here comes from that selected item downwards till the first item. Similarly, take the fourth item now. First, second, third and fourth item. So this is the key item. 80. Compare with its previous. Previous is 70 now after interchange. 80 and 70, no need to interchange. They are in position. 70 and 20 already, and 20 and 10 already in position. Correct? Next, take the fourth item. 30. 30 with the previous item. 80. Yes, you need to interchange. 30 comes here and 80 goes here. 30 with its previous, go down, right? 30 and 70, yes. 30 comes here and 70 goes here. 30 and its previous, as it is. 20 is less than 30, so no need to compare. And even 20 and 10 already no need to compare. Are you getting this? So overall, from the given item, we come down the array till the first index, till the first item. Correct? Each time you compare with its previous item. If interchange is required, you interchange. And again the comparison continues down the array. So totally, by the end of these passes, these are also called passes. First, starting from the second one till you go down. So it is just like second one to first one. Next, third one, second one and first one, like this. And take the fourth item, fourth to third to second and the first item. And similarly, so from each selected key item, go down those many comparisons and if required, interchanges. So that is how it is called insertion sort. Taking an element or item as the pivot or the key item, we find an appropriate position to insert the already sorted portion of the array. Now if you observe this much portion is already sorted, correct? When you take an array, the previous items are already found to be in sorted order, correct? So that means the selected item, we are finding a location for it to be inserted in the already sorted portion of the array. So partially the array is getting sorted. When you move from one item to another item, we see that the elements will be sorted in partial amounts. Partially they are getting sorted. So until we reach the last item, and later we find that it is completely sorted. So insertion sort works according to this algorithm. Now let us write this algorithm. So before writing the algorithm, there are two loops required for any sorting algorithm, correct? Normally two loops are required. One loop is the outer loop, which will take care of the number of passes. How many times the comparison of the two items has to be done. How many times? That is taken care of by the outer loop, which is controlling the number of passes. Here also there are 4 passes. 1, 2, 3 and 4. Because the first item is already in its position. When you do the first comparison, it is already into its position normally, right? So when there are 5 items, there will be 4 passes, and the outer for loop will take care of the number of passes, and the inner for loop will take care of the interchanges, if any, depending on the condition. What condition? Whether we require to put the items into the ascending order or descending order, we require to interchange, right? So in this case, ascending order, so the first item should be less than the next item. That is why we compare whether the selected item is less than its previous. If less than its previous, you need to interchange, right? So one outer for loop for the sake of controlling the number of passes, and the inner loop is to interchange. So let us write the algorithm now, right? Now let us see this algorithm. Algorithm already I have written to save time. Step 1. For I is equal to 1 to n minus 1. As I have taken the first outer loop, we will take care of the number of passes. 1 to n minus 1. If there are n items in the array, 1 to n minus 1. Total n minus 1 passes. If there are 5 items, there will be 4 passes. Outer form. Step 2. Look at this. J is equal to I. To begin with, initialize the second loop index, inner loop index j is equal to I. It is not 1. J is equal to I. Right? It may change later. J is equal to 1, 2, 3, etc. till n minus 2. Step 3. While j is more than or equal to 1, inner loop, as we have seen, it is the downward loop. Starting from the given item, we go down the loop, down the array, by comparing its previous item, right? That is why, while j is more than or equal to 1, starting from the given value of I, so thus I will be, this is used to select the key item, right? Select key item. Key item is the pivot item, as I told. Selected item 1, comparing to its previous. So while j is more than or equal to 1, if a of j is less than a of j minus 1, a of j, the given item, the selected item, is less than its previous, j and less than j minus 1, its previous item. So interchange. This one, 3 statements, already you know it. The 3 statements to interchange the values of a of j and a of j minus 1. Using the third variable temp. Temp is a of j is a of j minus 1, a of j minus 1 is equal to temp. So that is the end of it, end of j and end of the while and for loops. Correct? So as we have seen here, selection of an item, second index, second element or index 1, starting with the cj. For I is equal to 1. Let us see this, how this happens in this example. Right? So when you select I is 1, j becomes 1, j is 1. For I is equal to, now I is equal to 1. So j becomes 1. While j is more than or equal to 1, j is 1. More than or equal to 1 is true. So into that. A a of 1 is 70 less than a of j minus 1, a of 0, a of 70 is more than, sorry, less than a of 0, 10, true, a of j is this one, index 1, a of j is less than a of j minus 1, it is less, no, false, a of j is not less than a of j minus, are you understanding? A of j is 1 here, I is 1, j is 1, a of 1, 70, less than a of j minus 1, less than 10, no, false, so this is false, this will not happen. So next, j becomes j minus 1, end of if, and j becomes j minus 1 for that while loop. J is 1 now, j minus 1 becomes 0. Now look at the loop, while loop. 0 is more than or equal to 1. False, correct? Loop is false, so it is out of the while loop, but it is still in the for loop. Outer for loop, I becomes 2 now. First we have seen, so j becoming 1 and j becoming 0, this loop terminates. So back to I. Now I becomes 2. I becomes 2 here. So j becomes 2 to start with. While j is more than or equal to 1, j is 2, more than or equal to 1 is true. If a of 2 is less than a of 2 minus 1, a of 2, this one is 0, 1, 2, 3, 4. Now a of 2, 20 is less than 70. 20 is less than the previous item is 70. Right? 20 is less than the previous item 70. True or false? True. 20 is less than that. It is true. So you have to interchange. So this 20 and 70 are interchanged using this one. I need not have to go into the details of that. It will be interchanging of 20 and 70. So 20 comes here, 70 goes here, correct? At the end of this one. So j is equal to j minus 1. So here j was 2, right? J becomes j minus 1, 1. Now j becomes 1. Again into the while loop. 1 is more than or equal to 1. True or false? True. 1 is equal to 1. True. Again into the if. Into the while loop. If a of j is how much now? J is 1 only. J is 1. Just now j becomes 1. A of j, it is a of 1, 20. Less than its previous. 20 less than 10. True. No. False. 20 is more than 10. They are already in position. Correct? 20. 10 previous. Right. So this is false. No need to interchange. Correct? So carefully go through the statements and the error items. No need to interchange. So next becomes j is equal to still j minus 1. J is equal to 0. So when j becomes 0, here 0 is more than or equal to 1 becomes false. So it also comes out of the while loop. So while loop ends here. Again I becomes 3. Now look at this. For I is 1, j becomes 1 and 0. For I is 2, j becomes 2, 1 and 0. So naturally for I is equal to 3, j must become j is equal to 3, j is equal to 2, j is equal to 1 and j is equal to 0. From 3 comes down until 0. When j becomes 0, loop is terminated, correct? The while loop is terminated. So in the similar way, j becomes 3 now, I has become 3, j becomes 3, j is 3. While j is more than or equal to 1 is true, a of 3 is 80. 80 less than previous item 70. 80 less than 70. No, false. 80 is more than 70. It is false. It does not go into that. J becomes still j minus 1. J becomes 2. J becomes 2 here. 2 is more than or equal to 1 is true. Into that, a of 2. A of 2 is 70. 70 is less than this one, 20. True. It is already done. 70 is less than j minus 1, 20. False. Right? So loop if condition is false. So this will not happen. J becomes once again 1. J becomes 1 now. Right? Now j becomes 1. 1 is more than or equal to 1 is true. Into that, a of 1, 20 less than 10. No, because already we have seen those. So false. Now j becomes 0. J becomes 0 and while loop terminates. while loop terminates. Back to the next value of I. Now similarly I becomes 4. I becomes 4. The last round of I, 4 passes. I becomes 4. Same thing will happen. So j is equal to 4. J is equal to 3, 2, 1 and 0. Correct? Let us see that. J also becomes 4. A of, so 4 is more than or equal to 1 is true. A of 4 is less than A of 3. A of 4, 3 less than A of previous 80. True. Interchange. So interchange means 30 comes here and 80 goes here. Interchange. J becomes 4 minus 1. J becomes, this is over. J becomes 3. 3 once again more than or equal to 1 is true. A of 3 is less than A of 2. A of 3 is 30. A of previous 2 is 70. 30 is less than 70 is true. So once again into the interchange. 30 and 70 got interchange. Look at this. This is the new position. 30 and 70. J becomes 1 less still. J becomes 2. 2 is more than or equal to 1. True. Into the if. A of 2 is less than A of 1. A of 2 is 30 is less than 20. No. Right? 30 is less than 20. No, false. So it will not be interchanged. J becomes 1 less still. J becomes 1. 1 is more than or equal to 1 true into the if. A of 1 is previous A of 0. A of 1 is 20. 20 is less than 10. No. They are already in position. Right? No interchange. J becomes 0. J becomes 0. But the while loop condition becomes false now. Right? So while loop stops. And back to the next value of I. How much? I so far was 4. But I5 is invalid because I is from 1 to n minus 1 only. How much is n? N is 5. N minus 1 is 4. Already we have done 5. Which is I is equal to 4. But I becoming 5, this loop is also terminates. Correct? Outer loop is also terminating. End of for, and this is the end of the algorithm. Now let us see the array items, whether they are sorted or not. See? Array items. 10, 20, 30, 70 and 80. They are sorted. See? 10, 20, 30, 70 and 80. So this is the latest position of the items in the array. So the array gets sorted. I will write here. So the finally sorted array is 10, 20, 30, 70 and 80. So this is how we sort using the insertion sort. Correct? Hope you have understood this algorithm, and tracing of an example I have shown, that also you might have understood. Thank you.